Hello everyone, I'm Sung-il Kim in the School of Management Engineering at UNIST. In this video clip, we will talk about linear algebra notation and arithmetic such as vector, matrix, tensors, linear function, affine function, which are crucial concepts in data science. These are important because by learning them, you can read descriptions of existing algorithms in textbooks. You can interpret and implement descriptions of a new method in research papers. And you can concisely describe your own method to other practitioners. A vector is an ordered list of numbers. Here is a vector A. Numbers in a vector are called entries, coefficient, or element. The length of vector is its size, length, or dimension. Okay, this vector A has dimension 4, and its second element is 2.0. A vector of length n is called an n vector. Here are examples of vectors in our real life. Latitude and longitude are the units that represent the coordinates at geographic coordinate system. The longitude and latitude at UNIST is actually 35.575 and 129.186, which is also a vector with size 2. RGB vectors represent colors. Here are 6 colors with corresponding RGB vectors. 2 vectors having the same size can be added element by element. Subtraction is similar. There are some properties of vector addition such as commutative and associative. Scalar vector multiplication is defined like this. There are associative, left distributive, right distributive properties regarding to scalar vector multiplication. Inner product of n vector A and B is A transpose B. Some other notations are also used commonly for inner product. There are some properties in inner product and some simple examples. We can pick out ith entry using inner product, and also we can express sum of entries, sum of squares of entries using inner product easily. Next, let's talk about norm. Norm is used to measure the size of a vector. The Euclidean norm of an n vector x is square root of sum of squares of entries, which is square root of inner product of x. When n equal to 1, the norm reduces to absolute value. For any n vector x and y and any scalar beta, there are properties such as homogeneity, triangle inequality, non-negativity, and definiteness. Actually, we can regard norm as a function. Each input is a vector and output is a scalar. In that sense, norm can be used to compare size of vectors of different lengths because the output of norm of any vector is a scalar. For example, mean square value, root mean square value are functions of a vector. In statistics, we call such a function of data statistic. Norm is also used to define the distance between n vectors A and B. RMS of A minus B is the RMS deviation between A and B. When the distance value is large, we say that they are far each other If they are small, then we say they are close. This distance concept is very important in optimization because it is related to loss function, which is objective function of optimization problem in many cases. A typical loss function is the distance between the output value we found and the true value. Let's move to matrix. A matrix is a rectangular array of numbers. For example, here. Its size is given by row dimension times column dimension. The size of this matrix is 3 by 4. Entries are also called coefficient or element. The element at ith row, jth column of matrix B is denoted by Bij. We say two matrices are equal if they are the same size and corresponding entries are all equal. For n by n matrix A, we call A tall matrix if m is greater than n. Wide matrix if m is smaller than n. And square matrix if m equals to n. We consider an n by 1 matrix to be an n vector and 1 by 1 matrix to be a number of a scalar. A 1 by n matrix is called a row vector, while n by 1 matrix is called a column vector or just vector. Note that row vector and column vector is not the same. Matrix vector product of n by n matrix A and vector x denoted by y equal to ax. Y is a m vector and each element of it is as follows. For example, 2 by 3 matrix is multiplied by a vector with size 3 becomes a vector with size 2. What about tensor? A tensor is a generalization of vectors and matrices, and it is easily understood as a multidimensional array. Now, let me introduce the concept of linear dependence and independence. For that, we need to define a linear combination first. Suppose we have n vectors and m scalars, beta 1 to beta m, then n vector beta 1 a1 plus beta 2 a2 up to beta m am is called a linear combination of the vectors, and a1 to am, beta 1 to beta m are called the coefficient of the linear combination. Set of n vector is linearly dependent if the linear combination of them equals to 0, holds for some coefficients that are not all 0. Similarly, set of n vector is linearly independent if it is not linearly dependent, or the linear combination of them equals to 0 holds only when all coefficients are 0. For example, unit vectors are linearly independent. The concept of linearly independent is very important in data science because it is directly related to matrix factorization and dimension reduction techniques. Now I'm going to introduce linear and affine function. Consider a function f mapping n vectors to numbers. F satisfies superposition property if for any numbers alpha, beta, and n vectors x and y, this equation holds. We call a function that satisfies superposition linear. The inner product we already discussed in the previous slide is a kind of linear function. Let's see why. We can easily show that the inner product function is linear by checking the superposition property as shown here. Actually, its converse is also true. We can show that all linear functions are inner product. A function that is linear plus a constant is called affine. Its general form is f of x equal to a transpose x plus b, with an n vector a and a scalar b. So a function f is affine if and only if superposition property holds for all alpha and beta with alpha plus beta equal to 1. And sometimes people refer to affine function as linear. For example, a regression model is actually the affine function of x. Regression model is used to identify the relationships between two vectors x and y. X is a feature vector or independent variables, and y is an actual outcome or dependent variables. And vector beta is the weight vector or called parameters in statistics. Those parameters can be estimated from data. The scalar y hat is the prediction value. You will learn regression model in detail in the data mining course. In this video clip, we talked about a linear algebra notation and arithmetic such as a vector, matrix, tensor, linear combination, linear independence, linear function, affine function, and so on. I hope this video clip helped you to get motivated to study linear algebra and based on that to understand main concept in data science. Thank you.